Utricle of the inner ear. The utricle is larger than the saccule and is of an oblong form, compressed transversely, and occupies the upper and back part of the vestibule, lying in contact with the recessus ellipticus and the part below it. This is a picture of the inner ear. These are the three semicircular canals. This is the vestibule where inside the utricle is located. It's an enlargement showing the cochlea and the semicircular canals and in between the vestibule. Now if we expand the vestibule, that is where the utricle is located. The macula of the utricle is a thickening in the wall of the utricle where the epithelium contains vestibular hair cells that allow a person to perceive changes in latitudinal acceleration as well as effects of gravity. I repeat, latitudinal acceleration. The gelatinous layer and the Stereocilia together are referred to as the otolithic membrane, whereas the tips of the Stereocilia and Kinocilia are embedded. I repeat, the gelatinous layer and the Otoconia together are referred to as the otolithic membrane, and it is in this, the otolithic membrane, where the tips of Stereocilia and Kinocilium are embedded. When the head is tilted such that gravity pulls on the Stereocilia, the gelatinous layer is pulled in the same direction, also causing the sensory hair cells to bend. Within the utricle is a small 2 to 3 millimeter patch of hair cells, and this is called the macula. The macula of the utricle lies horizontally on the floor of the utricle and contains hair cells. These hair cells are mechanoreceptors consisting of 40 to 70 stereocilia, but only one true cilium called kinocilium. The kinocilium is the only sensory aspect of the hair cell and is what causes hair cell polarization. The tips of these stereocilium and kinocilium are embedded in a gelatinous otolithic membrane. This is the vestibule. In that is the utricle, and in the floor is the macula of the utricle. The macula has three layers, and embedded in this are the hair cells, of which there are multiple stereocilium but one kinocilium, and the tips are embedded in the otolithic membrane. And embedded in the otolithic membrane are the stones, also called otoliths. This membrane is weighted with calcium carbonate, as we saw earlier, protein granules called otoliths. The otolithic membrane is embedded with calcium carbonate stones called otoliths. The otolithic membrane adds weight to the tops of the hair cells and increases their inertia. What a beautiful structure this is. The addition in weight and inertia is vital to the utricle's ability to detect linear acceleration and to determine the orientation of the head. Again, let us have a look at this diagram. Embedded in the otolithic membrane are the Otoconia that gives it the weight, and because of the weight, it gives it the necessary inertia so that when the head accelerates forwards, this remains static, this moves, and as a consequence, impulses are elicited that travels via the nerve cells. Microanatomy. The macula consists of three layers. The bottom layer is made of sensory hair cells which are embedded in the bottom of a gelatinous layer. Each hair cell consists of 40 to 70 stereocilium and one kinocilium, and this is the most important receptor. These are the stereocilium scanning electron microphotographs. That is the kinocilium, several stereocilium 40 to 70, but one kinocilium. On top of this layer lie calcium carbonate crystals called Otoconia. The otoliths are relatively heavy, and this provides weight to the membrane as well as inertia, thereby allowing for a greater sense of gravity and motion. Labyrinthine activity responsible for the nystagmus induced by off vertical axis rotation arises in the otolith organs and couples to the oculomotor system through the velocity storage mechanism. That portion which is lodged in the recess forms a pouch or a cul-de-sac, the floor and anterior wall of which are thickened and form the macula acoustica utriculi, which receives utricular filaments of the acoustic nerve. The cavity of the utricle communicates behind with the semicircular ducts by 5 orifices. The ductus utriculosacularis comes off to the anterior wall of the utricle and opens into the ductus endolymphaticus. Again, an enlarged view of the semicircular canal, the vestibule, the utricle, and an enlarged view of the utricle, wherein in between is the endolymph as well as the embedded otoconia. The utricle contains mechanoreceptors called hair cells that distinguish between degrees of tilting of the head thanks to their apical stereocilia setup. These are covered by otoliths which, due to gravity, pull on the stereocilium and tilt them. Depending on whether the tilt is in the direction of kinocilium or not, the resulting hair cell polarization is excitatory, which is depolarizing, or inhibitory, which is hyperpolarization respectively. Any orientation of the head causes a combination of stimulus to the utricle and saccules of 2 ears. The brain interprets head orientation by comparing these inputs to each other and to other input from the eyes and stretch receptors in the neck, thereby detecting whether only the head is tilted or the entire body is tipping. The inertia of the otolith membrane is especially important in detecting linear acceleration. Suppose you are sitting in a car at a stoplight and then begin to move. The otolithic membrane of the macula utriculi briefly lags behind the rest of the tissues, bends the stereocilium backwards, and stimulates the cells. When you stop at the next light, the macula stops, but your otolithic membrane keeps going for a moment, bending the stereocilium forward, and this is how you perceive linear movement. The hair cells convert this pattern of stimulation to nerve signals and the brain, and is thus advised of changes in your linear velocity. This signal to the vestibular nerve, which takes it to the brain stem, does not adapt with time. The effect is that, for example, an individual lying down to sleep will continue to detect that they are lying down hours later when they awaken. An otolith, ear lith stone, also called Otoconia or statolith, is a calcium carbonate structure in the utricle of the inner ear as well as in the saccule, specifically in the vestibular system of vertebrates. The saccule and utricle in turn together make the otolith organ. These organs are what allows an organism, including humans, to perceive linear acceleration both horizontally and vertically by gravity. They have been identified in both extinct and extant vertebrates. Because of the orientation in the head, the utricle is sensitive to a change in horizontal movement, and the saccule gives information about vertical acceleration as when in an elevator. So, the next time you go in an elevator vertically up, you must realize that it is your saccule that is giving you the information. Stereocilia, also called Otoconia, are numerous grains, often spherical in shape, between 1 and 50 micrometers collectively. Otoconia also sometimes called a statocyst. Otoliths, also called statoliths, are egg-glutenated crystals or crystals precipitated around a nucleus with well-defined morphology, and together all may be termed the endolymphatic infillings. This is a beautiful picture of the otoliths. This is one single otoconia enlarged. Let us have a look at the fine surfaces of a single otoconia. This beautiful picture shows the fine chiseled surfaces of a single otoconia. Otoconia are made up of inorganic calcium carbonate crystallites and organic substance, which is thought to be sulfated glycosaminoglycans and glycoproteins. Mouse otoconia are formed in situ, and the primitive otoconia assume spindle, trigonal, dumbbell, or quadril-lobed forms. As the otoconia mature, they assume the typical barrel-shaped body with pointed tips formed by three surfaces. A variety of otoconial disorders have been reported. Otoconial degeneration can result from ototoxic drugs, infection, trauma, aging. Abnormal otoconia are also known to occur as a result of genetic mutation as well as ototoxicity. Otoconial deficiency may be genetic or caused by certain drugs such as carbonic anhydrase inhibitors or tetracycline, or manganese deficiency during the critical period of gestation when the otoconia are formed in utero. Otoconial deficiency has been found to produce head tilting, swimming difficulty, and reduction of failure of the air righting reflexes in animals. In mammals, otoliths are small particles composed of a combination of gelatic matrix and calcium carbonate in the viscous fluid of the saccule and utricle. The inertia of these small particles causes them to stimulate hair cells when the head moves. The hair cells are made up of 40 to 70 stereocilia and one kinocilia, which is connected to the efferent nerve. When the body changes position or begins a movement, the weight of the membrane bends the stereocilium and stimulates the hair cells. Hair cells send signals down sensory nerve fibers, which are interpreted by the brain as motion. So now you know how you detect linear acceleration. In humans, vestibular evoked myogenic potentials occur in response to loud, low frequency acoustic stimulation in patients with sensorineural hearing loss. It is therefore now ascribed to have a slight effect on hearing as well. I repeat, in humans, vestibular evoked myogenic potentials occur in response to loud, low frequency acoustic stimulation in patients with sensorineural hearing loss. Vestibular sensitivity to ultrasounds has also been hypothesized to be involved in the perception of speech, potentially at artificially high frequencies above the range of the human cochlea, that is less than 18 kilohertz. So, therefore, now we ascribe a slight function of hearing as well to the otoconia as well as its entire component of the utricle. Now, here we have a comprehensive review of the utricle of the inner ear.